plus or minus 1 over plus or minus 1 into. Excuse me. It's a fourth degree polynomial. I have up to 5 terms in it, and I could have up to 4 possible zeros. Whether or not I have reals or imaginaries, I don't know until I get started. So I start with 1. And I usually start with 1 because it's the easiest. And see where it leads. So as you go through this, you drop the first term, multiply, add, multiply, add, multiply, add, multiply, add. And you get a 0. So you have a 0 at 1. So I know this is a 0, which makes my term then x minus 1. So I write that off to the side so I keep it tally. Now, yesterday I made a quick little mention that it's not a bad idea to start checking for what we call multiplicity. Remember, multiplicity means you can have the same 0 multiple times. So it's, if you recall when we had graphs, it's where it changed direction on the axis. So I'm going to take 2 seconds and check one more time just to see if it worked. And right away I know it's not going to. So I don't worry about it. So I go to -1 and I erase what I had. Don't do synthetic division in pen. You'll use a lot of paper. Let's see here. 2, -2, 1, -1, 1, -1, and a 0. Yay! I have another 0 then at -1. Now you're at the point where you have the quadratic 2x squared. Oh, hi, Devin. We're at the quadratic now of 2x squared plus 1x plus 1. And this means what times what is 2, you add together to get 1. That'd be -1. No. Which means in order for this one to work, you'd have to use the quadratic formula because you get imaginary solution. So your only real zeros will be at plus or minus 1 for this one. No, all you do is find reals. We're going to talk about why imaginary solutions occur today. Okay. Right. Does that make sense on that one? What did you have, Abby?
That was the last time.
That's fine. What do you have?
57.
57. Okay.
Yeah. Oh, yeah. I think I mixed them.
All right. Ladies and gentlemen, come on. Again, I'm going to start with the idea of working with my possible zeros. So I have plus or minus 1. We get 2, 4, 8, and 16 over 1 and 2. Okay. From there, excuse me, we start out. Why am I putting placeholders in? Because you're missing values. Okay. Remember, yeah, those missing values will get you. Okay. So you start with the missing values and work off of that. So we go 2, 2, 3, 3, 3, 3, 3, 3. Not going to happen. -1, 2, -2, -1, 1, 1, -1, -1, 1. Again, not going to happen. I go to 2. Oops, sorry. And I get 1. Okay. I get 1 at 2. Excuse me. So I have an x minus 2. Again, like I was saying earlier, it doesn't hurt to check for multiplicity. And right about now, you can tell it's not going to get there because everything's positive. You're not going to get there. So I'll go back and change that to a negative. Change that up to a negative. We have negative 4, 1, negative 2, 8, negative 16, 4, negative 8, and I'm happy again. Okay. So I have terms of x minus 2, x plus 2. Now, take a look at your coefficients you have now. We're now dropped to a third degree polynomial. I have 2x cubed, x, yes, ma'am. Oh no, you can do that too. Yeah, absolutely. The only reason why I'm stopping is because I recognize real quick that these numbers, if I split them out, if I take a 4 out of the 8, I'm going to have GCS, won't I? That's the only reason why I stopped, because I recognize the pattern of 2, 1, then I have an 8 and a 4. Those guys I can bring out a 4. But yeah, absolutely. You can always check your multiplicities here. So I know I have a 2x cubed, x squared, 8x, and a 4. And pull GCFs. X squared, I have an x. So you have a 2x, 1, a positive 4, and I have a 2x, plus 1. That gives me my other terms now at 2x plus 1 and x squared plus 4, which gives me, yeah, it will be imaginary, which means I have zeros at 2, negative 2, negative 1/2, and a non-real answer. Right? And that's what we're getting at. Hi. Do you have money? Then leave. I don't know. Which one does this look like? What's this one? and sorry. Come on. I wouldn't be me if I didn't do that, right? That's true. So, and in this case here, you wind up with imaginary solutions, and yesterday. Again, guys, this whole process of everything that we've been doing is leading us now to getting us to this next step. Okay, and this next step is kind of a big deal, and this is where we're at today. So hold that for now, because that was mainly practice to get you continually used to synthetic, because like I had mentioned, synthetic division is your best friend when it comes to factoring. Now, sorry, what this gets to now is the idea of why everything that we have done throughout the course of all of Chapter 6, when it goes back to the why did we talk about dance moves? Why did we talk about nth degree? Why did we talk about possible changes of direction? Why did we talk about how many terms can be in a sequence? Why did we talk about how many possible zeros there can be? Everything comes back to this idea of what's called the fundamental theorem of algebra. Yesterday, I think I told you guys, you know how we talk about in terms of education, there are certain educational standards, if you will, that you learn about, that we are to teach about, I should say? Well, in high school math, or basically in algebra, I think there's about 35, 36-ish or so of them. And just this one topic covers 14 different standards in algebraic math. Exactly. And believe it or not, you guys have dealt with this forever. Now, it's been a long time, but if you think back 8, 9 years ago, you guys did stuff like this. No. You guys did stuff like that. About 7, 8 years ago, when you guys first learned about this crazy thing called addition, you started talking about what do you add 1 to make it. Oh, Devin, are you okay? Can you not hear me? Can't hear you, Devin. Hey, Devin. Oh, there's Devin. Devin, can you hear me now? Hello, Devin. I can hear you. I can hear you. Try this one. No. Let's do this. Let's restart it. We'll try again. Oh, it did. There it goes. Oh yeah, maybe they will. Maybe they can hear me now. I'm trying. Oh, she turned down the volume. Oh, hello. I'm back. Sorry about that. Apparently I didn't open up the microphone. That was my fault. I'm new at this. All right. So back to this one again. Back in good old-fashioned kindergarten, you guys did this where you had something plus 1 is 3. What was the something? 2. Okay. Now after kindergarten, you guys went on first grade, second grade, so on and so on. It started to become a little bit more complex, where you did something like this: 2x plus 1 is 5. I'm saying, all right, 4th, 5th grade, whatever. Guys, again, when you had a value of x, there was always going to be what? A solution. There was always some value of a solution. You were always able to get some answer. You knew that there was an answer out there because you were solving for x. What changed when you got down to quadratic stuff? You had x squared equal 4. What would you do? You square root, and you square rooted it, and how many answers did you get? 2. You got a plus or minus 2. Now, the reason being is because every single time that you had some value of x that you were solving for, whatever that nth degree was, told you how many answers you had to have. So the entire time throughout your whole math career, from kindergarten to x plus 1 was 3, you had been working with what we call the fundamental theorem of algebra. The fundamental theorem of algebra is basically, for whatever number of values of x you have, there's going to be some answer. And you guys have been finding the answer all along. You just didn't know that's what it was called. What's that? But yeah, that's kind of where all this comes from. So think about what we've been doing. We've been working through all of these silly standards all along. Like, I'm not kidding. There was like 14 of these things you guys had to do. And like I said, this is why algebras. Because for every single value, for any value of a polynomial, for example, here we have a 4th degree polynomial. If we go through all the stuff that we've learned about it from now on, or from the past couple of weeks, 4th degree polynomial, it's 4th degree. How many terms are in its sequence? 5. There's 5 terms. What are the dances doing? Dances are up, up. The reason that they are up, up is because why? It's positive coefficient, even exponent. Now, the dance is up, up. How many times is it, how many possible? Yeah, direction changes, yep. How many? 3 of them. There's 3 possible changes in direction. Does it necessarily have to use all 3? No. And then when it comes to that then is how many possible zeros will there be? 4 of them. There are 4 possible zeros. And as you know now, zeros are your solutions. How many answers should you get? You should get 4. Why? Because it's a 4th degree polynomial. Does it say that it has to be real or it has to be imaginary? No. Isn't an imaginary solution still a solution? Yeah. So all along, you just can't see it. All along, we've been solving for x forever. The reason that you can solve for x is because when you have a linear equation, 2x plus 1 equals 5, you've got one answer. X squared equals 4, you've got 2 answers. X cubed equals 9, or when you work through it, you could get up to 3 answers depending upon the probability, or not probability, but the scenario of the problem. Okay? It all is dependent upon all of this. Whatever your degree is of a polynomial, that's how many answers you're going to get. No matter what. That's how algebra is. This is what we're doing. What you've been doing all along. You just didn't know it. This is kind of cool. So, let's look at these two. Find me all of my zeros. There are many ways to do these. Think about the possible ways of solving and factoring and getting zeros. You know how to group. You know how to factor like a trinomial. You know how to use the quadratic formula. Excuse me. You know how to use synthetic division to become your best friend. There are multiple ways of going about doing these. But for one thing, x to the 4th plus x squared minus 12, you know for dead certain how many answers should you have? 4. Yeah, you have to have 4 because it's a 4th degree polynomial. Okay? Because that's way mathematics. Take a second to figure that out. Do you guys remember the trick for that first one? 4th degree, 2nd degree, constant. What are you going to factor it like? Normally. Factor it like you would normally. Factor it just like a regular trinomial. You don't have to erase it. You're not doing it wrong. You're going to get the same answer. Now, what I'm saying is, in this case here, remember, if your degrees get cut in half, and you have a constant, and they're even, treat it like you would. What times what's negative 12 you add together to get 1? 4 negative 3. So I have x squared plus 4, x squared minus 3. Now that's going to really easily now generate zeros, isn't it? I have zeros now located at plus or minus 2i and plus or minus the square root of 3. So today, yeah, you will take that step further and throw in all your imaginaries. Okay? How many zeros do I have? 4. How many should I have? 4. Yeah, exactly. Now, the second one, again, the second one is another setup that's kind of leading you to do one specific method, grouping. And remember, when you have grouping, it's usually a dead giveaway that it wants you to group when you have 4 terms, when you have 4 terms and they're all in descending order, okay? If they're all in descending order, it works out rather cleanly. So it's always worth a shot to try it. What's your GCF? Please don't pop it. That drives me nuts. Thank you. X squared. Then I'm left with an x plus 5. On the other one, I'm going to take out the -9 and multiple with an x plus 5. Gives you now zeros at what are your tails doing on that one? Down, up. Where's across the x-axis? -3, 5, -3, -5, and +3. Where's your y-intercept on that one? Exactly. All these little bits of things that you can pick up on just from looking at the actual problem, you can figure out where everything goes. Okay? Ooh, math. And we did that. That was easy. Let's do this one. Find me all of my zeros. Where are my zeros? Hello, zeros. Where are you? Find you, please. ¿Dónde están zeros? Hola. I've never said it. So when you go through it, you guys just start thinking about the rules that we've been working with. Think about it in your factory. What's always? GCF. What's your GCF? X. If you take an x out, what does that mean that you have a 0 at? 0. Now, that means you have a 0 at 0, which means that you have another set of terms, correct? So if I take an x out, I'm left with x cubed, 6x squared, 12x, and an 8. So I know I have a term of 0 that comes out that generates a 0 at 0. Now I have 4 terms in my sequence, descending order. Check and see if you can group it. Can I? No, I can't. Now that tells me that I have to do something else. Not the quadratic formula because it's not a quadratic. I have to use synthetic. So I'm going to check my zeros now at plus or minus 1, 2, 4, and 8 over 1. So as you start building into these problems, you're going to mix together multiple styles of solving the problem. Okay? Excuse me. In this example, we start at 1. Is there any rhyme or reason to start at 1, or do I can start at 8? Does it matter? It's just normal that you start at the top and work your way down. Or at the bottom and work your way up. Is that what that means? I don't know, whatever. They're 1, 6, 12, and an 8. And nope. Right, and you're starting to pick up on that, aren't you? So close, but yet so far. Yeah, not going to happen. Not going to happen. Yay! We get a 0 then at negative. If negative 2 gives me a 0, what's my term? It's 2. So over here on my side, I'm keeping a running tally. I have my zeros and my terms. And now I'm at a quadratic, aren't I? I'm at a quadratic of x squared plus 4x plus 4. What times what's 4 you add together to get 4? 2 and 2. It's got multiplicity 3 times at negative 2. What is that? If I'm not mistaken, when you have multiplicity 3 3 times, when it's an odd amount of time, it just goes through it on the graph. Whereas if it's an even amount of times, it changes at it. It's been a while since I've checked it, but I believe that's what that looks like. I think so. What was this one? Was what, X? Oh, can't type that fast. And a partridge. Yeah, see how it just goes through it? Yeah, it goes through it at 2. So it would be tough to decipher from a graph how many zeros it has. Yeah. So whereas if it had an even amount of them, it would change directions on it and then go through like that. When it has an odd amount, I believe it just goes through it. This is something I wouldn't make you graph like that. When I graph stuff with you guys, when we talk about multiplicities, I will keep your multiplicities to 2, because you know it changes direction, and I'll give you up to another zeros. But that's what we're doing. Okay, oops. So there you go. There's a 4th degree polynomial and had how many zeros? Convenient, isn't it? It had 4 zeros, even though one of them had multiplicity of 3. Last one, and we'll call it a day. Factor it out and find all of my zeros, please. The second part of this, we'll start up tomorrow. It doesn't take as long, but it takes about 15 minutes or so to go through. And believe it or not, I've been prepping you for it all along. Because if 2 is your 0, what's your term? If -4 is your 0, what's your term? If 2i is your 0, what else does it have to be? -2i. It had to be the square root of negative. So remember, imaginary numbers, they always come in pairs. So little things like that, we've been prepping all the way through. You just didn't know we've been working on it. Because tomorrow I'm going to have you guys build polynomials given zeros. Because if you have 4 zeros, what does your degree have to be? I'll give you a hint. 4. Okay. How's it going? Oh, sweet. Hey, does anybody know who this is? Take a look. Anybody know who this is? Anybody? Devin, do you know who this is? Yeah. So, you're pointing me in nerds. Do you think it's ever bothered me to go out and make a fool of myself? Do you think it's ever mattered? No, I'm not. Jordan, I wasn't making fun of you, was I? No, see? This is a slight difference. It's not a giant difference, but it's slightish. Now, this one right off the bat, do you guys all agree that you can't do anything but synthetic? This one's nice because you only have to worry about sixes, so that's easy. So it's plus or minus 1, 2, 3, and 6. This is when it's nice to have a smart board at home. No, thanks though. Did you guys remember to put a placeholder in? Oh! Where the negative, where the execute is. See, there's no execute. See, there's an execute. Fifth degree polynomial should have 6 terms. So you go through the process. 1, 1, negative 1, negative 1, negative 1, negative 1, 7, 7, negative 6, negative 6, and a 0. Look at that. All right, so 1 works, which means it's x minus 1. Check your multiplicity real quick. Hey, look at that. It's got multiplicity. How'd I get that? We okay? So I have, it's got multiplicity at x minus 1. Fifth degree, fourth degree, third degree. And you can probably tell that I'm not going to be able to group that. So I tried it 1 again, just might as well. Nope. Then I'll switch to negative 1. Not going to work. Was it 2? On the right track. There we go. So I have a 0 then at negative 2, so it's x plus 2. Now, this is my quadratic. X squared minus 2x plus 3. What times what's 3 you add together to get negative 2? Nothing. Nothing. So now, when you're at a quadratic, what do you have to fall back to? Quadratic. So you use your quadratic word. Remember, sing the song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So now you have your other zeros so far. My last 2 zeros, because the fifth degree polynomial, will wind up probably being weird or imaginary. We have 2 plus or minus the square root of 4 minus 4 times 1 times 3 all over 2. Okay? It's 4 times 3. 8 minus 12. I'm sorry, 8. Sorry. You're right. But how about this again? How about 4 minus 12? Negative 8. Thank you. It's 2a. Our value of a is 1. So I have 2 plus or minus the square root of negative 8 over 2. What's the square root of negative 8? 2i root 2. Good. So that gives me 2 plus or minus 2i root 2 over 2. What can you do when they're all 2's? In this case, since all parts are even, that's technically factoring out a GCF of 1. Okay? So you wind up with this equaling 1 plus or minus I root 2. Those are your other 2 possible zeros. We had 1, 1, and negative 2. And that gives me 1, little 2, little 3, little zeros, 4, little 5, little zeros. 1, little 2, little 3, something. One little 2, little 3, little 5, 6. No, it's not pigs. Is it monkeys?
I'm sorry with you all around them. A lot of yourself. That's what I would figure out when I heard it. I was like, I don't think I know somewhere. I was like,
On page 369. Yo, is it Indians? Oh. Is it really? All right. Yeah, I don't want to play that game, but we'll just say 1, little 2, little 3, little in there. 3 little zeros, 4 little 5. We'll call them zeros for. Oh, that's. Yeah, I'm just gonna quit while I'm ahead. Hey, everybody got pictures I can show what you look like walking around? Do those tonight, please. It is all, find all possible zeros. You will find out there are little tricks hidden without. Some of them are a lot quicker than others. What's that? You know the rules. Yes, ma'am. Yes, ma'am. In that case there, the reason why you can simplify that, one is because when you have 2 plus or minus 2I 2 over 2, the numerator has a GCF. It's 2. Now I'm simplifying over multiplication, not over addition. So if this was 21 and this, I can't do that. But I can do it by pulling them out. That's why that works. That's why that works. Are you supposed to get retakes today too? I was waiting for that door to go and you're like, yay. Thank you, ma'am.